Hello everyone, welcome to the series where we are covering topic-wise questions from previous year UPSC CSAT papers from 2016 to 2025. In the previous few sessions we covered questions on number system from previous year papers 2016 to 2023, and in this session we will cover some more questions on number system from CSAT paper 2023. So let's begin with the questions. Question number 1 is, a number n is formed by writing 9 for 99 times. What is the remainder if n is divided by 13? Okay. Now, before solving this question, first let's understand the divisibility of a number by 13. Okay. Now, to check the divisibility of a large number by 13, we divide a number into groups of 3 digits starting from right side, and then we add and subtract alternate numbers. Okay, and if the result is divisible by 13, then the number will be divisible by 13, right? Let's take an example. Suppose we have a number like 4 5 4 3 2 1 4 1. Now if we divide this number into groups of 3 digits starting from right side, right, then we have one block here, right, then another block. Now we are left with 5. Let us convert this number also into a 3 digit number. We can add two zeros, right. Now if we add and subtract alternate numbers, we get the result is equal to, now it will be 432 minus 141 plus 5, and it will be 432 minus 146, and it will be 6. Then we have 8, then 286. Now if 286 is divisible by 13, then this complete number will be divisible by 13. Now let's see. 286, 13, we have 2 here, and again we have 2 here, right? So 286 is divisible by 13. Similarly, this number 5432141 will be divisible by 13. Now let's try to solve this question. The given number is equal to 999 times. Okay. Now if we divide this number or group this number into blocks of 3 digits, then we will have 33 groups of 999. Okay, like 999, right? 999, 999. Okay, so there will be 33 groups. Now if we add alternate groups, add and subtract alternate groups, then we will be left with 999, right? Now if we divide, 999. Now if we divide 999 by 13, okay, let's see. Now we get here 8, 9, then we get 11. So if we divide this number, given number, by 13, we will have a remainder of 11. Okay, so right answer is A here. Now let's see question number 2. The question number 2 is, each digit of a 9 digit number is 1. It is multiplied by itself. What is the sum of the digits of the resulting number? Now if we closely observe the multiplication of a number which consists of all ones by itself, then it follows a certain pattern. For example, when we divide 11 by 11, then the product is 1 to 1. Similarly, if we multiply 3 ones with 3 ones, then the product will be 3 to 1 and 2 1. So this number is also following the same pattern. Now if we multiply a number consisting of 4 ones with itself, then again it will follow the same pattern and the product will be 4 3 2 1, right? Similarly on the left side, 3 2 1, right? Now if we multiply a number consisting of all ones, 9 ones, with itself, then the product will be 9 8 7 6 5 4 3 2 1. Similarly on the left hand side, 9 8 7 6 5 4 3 2 1, and the sum of all the digits will be equal to, if we add all the digits here, then the sum will be 81. So right answer is C here. Let's move to question number 3. What is the sum of all the digits which appear in all integers from 100 to 10 to 100? Now first of all, let's see the sum of all digits from 10 to 99. Now first first we add all the digits which come at units place. So sum of all unit place digits. Now all digits from, now all digits, that is 0 1 2 3 4 5 6, sorry, 6 7 8 and 9, right, appear 9 times when we count from 10 to 99, right? So sum of all digits will be 5 plus 6 plus 7 plus 8 plus 9 into 9, and it will be equal to 45 into 9, and it will be 405. Now sum of all tens place digits, now all digits, that is 1 to 9, will appear 10 times, right, from 10 to 99. Okay, and sum will be equal to 1 plus 2 plus 3, right, to 9 into 10, and it is equal to 45 into 10. Now it will be 450, right. We have one more number, that is 100, and sum of digits in 100 is equal to 1 plus 0 is equal to 1. Now sum of all the digits when we count from 10 to 100 will be equal to 405 plus 450 plus 1, and it is equal to 856. So right answer is B here. Now let's see question number 4. How many natural numbers are there which give a remainder of 31 when 1186 is divided by these natural numbers? Okay. Now all the numbers which give a remainder of 31 when we divide 1186 by that number will be equal to all the numbers which completely divide 1186 minus 31 equal to 5 5 1, right. And those numbers should be, and all those numbers should be greater than 31. Okay. Now let's see the factors of 11, 115. Okay. Now when we divide it by 33, we have 385, and again we have 5, uh, we have 77, then we divide it by 7, we get 11. So the factors of 1155 are 1, 3, 5, 7 and 11. So all the numbers which completely divide 1155, right, are 1, 3, 5, 7, 11, right. Then we have 15, then 21, then 33, 35, right. Then we have 55, then 77 and 105. Okay. Then 165. Okay. Similarly we have 231 and 385 and 1155 itself. Now we have already discussed that we need a remainder of if we need a remainder of 13, then the number must be greater than 31. Okay. So all these numbers which are greater than 31, okay, will give a remainder of 31 when 1186 is divided by these numbers. Okay. So how many numbers are these? 1, 2, 3, 4, 5, 6, 7, 8 and 9. So 9 is the right answer. Now let's see question number 5. Let P, P, Q, Q and R, R be a two-digit numbers where P is less than Q, less than R. Again, if PP plus QQ plus RR is equal to TT0, where TT0 is a three-digit number ending with 0. Consider the following statements. Statement 1 is the number of possible values of P is 5 and the number of possible values of Q is 6. Now let's see that we are given that PP, Q, Q and RR. If we add all these numbers, then the result is a three-digit number in the form of TT and 0. Now, we to prove that statement 1 is correct, we need to find at least one case which satisfies this condition. That is, when we add all these numbers, then we must get the sum in this form. Now let's see. When P is equal to 5, we we can have 55 here, then Q R R, right, T T 0. Now when this is 5, then Q R can be 1 and 4, right, to have 0 at a unit 0 at a units place, right. 5 plus 1 6 plus 4 10. Then let's see, do we get the result in the form and these numbers in the same form, right, whether this condition is satisfied. Now again, if we write, we have 5 5, then 1 1, then we have 4 4. If we add all these numbers, then let's see what is the sum of all these numbers. 6, 10 plus 11, right. So all these numbers are in the given format. Okay, so this condition is satisfied, so we can say that statement 1 is correct. Now let's see the statement 2. Now here the number of possible values of Q is 6. Now let's see, if P, now let's try Q is equal to 6, then the number will be 66 here, and we have R here. Now the sum should be in the format of T 0. Now when this Q is 6, we should have P plus R equal to 10, right. So we can have P is equal to 1 and R is equal to 3, then we will have 0 here. Now let's see if all the numbers and the sum is in the required format. Now here we have 1, then 6 6, then 3 3. Now 6 plus 3 9 plus 1 10, then 6 plus 3 plus 6 plus 3 9 plus 1 10 plus 11. So again the sum is in the required format. So statement 2 is also correct. So right answer is both 1 and 2 statement. Now question number 6 is, what is the sum of all 4-digit numbers less than 2000 formed by the digits 1, 2, 3 and 4, where none of the digits is repeated? Now all 4-digit numbers which are less than 2000 must have 1 at thousands place, and we can have any digit from 2, 3 or 4 at units place and tens place and hundreds place. Right. Now let's try to write all the numbers. The first number can be 1, 2, 3, 4 and 1, 2, 4, 3. Similarly, we can have 1, 3, 4, 2 and 1, 3, 2, 4 and similarly 1, 4, 3, 1, 3, 2 and 1, 4, 2, 3. Now if we add all these numbers, then sum is equal to 8, 9, 9, 7. So right answer is A here. Let's move to question number 7. What is the remainder if 2 raised to power 192 is divided by 6? Now if we closely observe this number, okay, now to solve this question we need to see what is the cyclic pattern of 2 raised to power n divided by 6. Okay, when n is equal to 1, 2 raised to power 1 is 2, and if we divide it by 6, then the remainder will be 2. Now when n is equal to 2, we will have 4 here, and if we divide it by 6, we get 4. Now when n is equal to 3, we have 8 here, and if we divide it by 6, we get again 2 here. Now when n is equal to 4, we have 16 here, and if we divide it by 6, we get 4 here. Right. Similarly, when n is equal to 5, we get 32 here, and if we divide it by 6, we get 2 as remainder. Now when n is equal to 6, we get 64, and if we divide it by 6, we get remainder 4. So we can see that when n is equal to odd, when n is equal to when n is an odd number, then remainder is 2, and when n is an even number, then remainder is 4. So here in the given question, n is equal to 1 by 192, which is an even number, so remainder will be 4. So right answer is D here. Let's move to question number 8. If question number 8 is A, B and C, D are 2-digit numbers. Okay, multiplying A, B with C, D results in a 3-digit number D, E, F. Okay, and adding D, E, F to another number G, H, I. D, E, F. Then result is 975. Okay. Further, A, B, C, D, E, F, G, H, I are distinct digits, and E is equal to 0, F is equal to N. Then what is the sum of A plus B plus C equal to? Right. Now if we closely observe this sum, we are given that E is equal to 0 and F is equal to 8. Right. Now when F is equal to 8, to have 5 at units place in the result, we must have I is equal to 7. Okay, so I is equal to 7. Okay, now if we add I and F, that is 7 and 8, we get 5 here, and we get a carry here. Now again E is 0. Now 1 plus H plus E is equal to 7. Now E is 0. 1 plus H, E is 0. We get 7. H is equal to 6. So H is 6. Right. Now G, D, when we add G plus D, we must get 9. So the possible pairs of G and D are 2763, okay, then 54, right, and 18, right. Now since I is equal to 7, we cannot have this pair, and we already have H is equal to 6, so we cannot have this pair as GD. Now F is equal to 8, we cannot have even this pair. So the only possible pair for G and D is 5 and 4, right. Again, when we multiply B and D, we get unit, we get F is 8 and E is 0, D is, we need to find it, right. Now when we multiply B and D, we get F, which is 8. Now only possible pair for B and D can be 2, 4, then we can have 2, 9, right, then we can have 3, 6, then we can have 1, 8, 7, 4, right, 8, 6, right. Now we cannot have this pair, and we cannot have this pair, and we cannot have this pair, right, even we cannot have this pair, right. So B and D is a pair which has got one of these number in common, right. So only possible pair is 2, 4, right. So we must have B and D 2 or 4, right. So we can again write this product as AC, right, 2, 4, if we multiply we get 0, 8, right. Now D is 4. So the only possible values for A and C can be 1, 3. Now we need to find the sum of A, B, C. Now here A is equal to 1, B is equal to 2, and C is 3, and the sum is equal to 6. Okay. So right answer is A here. So that's all for today. With this we have covered all the questions on number system from previous year UPSC CSAT paper 2023, right. If you find the session useful, then please like, share, subscribe and support our channel. Thank you.